Greenhouse Designer is a professional line design program that focuses exclusively on horticultural applications, including greenhouses and vertical farms. Derived from one of the industry standards in architectural line design software, Greenhouse Designer brings the power and certainty of professional line design and analysis to controlled environment agriculture. Greenhouse Designer is a software as a service, or SaaS, application, where all the lighting calculations are performed in the cloud. All that the user needs is an everyday web browser running on a personal computer, tablet, or even a smartphone. Unlike architectural line design programs, no software installation is required. The best way to introduce Greenhouse Designer and its features is to simply walk through the steps of designing lighting layouts for both a greenhouse and a vertical farm. So, having created an account, we can sign in with our username and password. Greenhouse Designer allows us to have multiple clients, and so we begin by selecting the New Client button. Each client can be assigned a name and address, and optionally their geographic location. So we create a client called Aardvark Farms and select the Save Client button to add the client to our account. Now, each client can have multiple projects, so we select the New Project button to create one. While there are many different greenhouse designs, most of them can be categorized according to the roof design style. The most popular ones are Arch, Gothic, Sawtooth, and Venlo. For vertical farms, we have a choice between tables and stacked trays in an enclosed room. For this project, we choose an arch greenhouse design, labeled geraniums, and select the Create button, which creates a project and returns us to the client page. We can now select the project title to begin work. Greenhouse Designer immediately creates a default greenhouse for us. The design is shown in both plan and elevation views, along with the key building dimensions. We now open the Greenhouse Dimensions tab, which presents us with a variety of dimension parameters. The explanation of these parameters is provided in the Series 365 plus Greenhouse Designer User Manual, but the design process for each of them is straightforward. We can, for example, change the number of bays wide from 4 to 6, and select the Update Schematic button to redraw the layout. The Build button will change the color from green to red when the schematic needs to be updated. Behind the scenes, Greenhouse Designer redesigns the building geometry without communicating with the cloud server. If we enter an invalid parameter, such as a wall height that is less than the roof peak height, Greenhouse Designer will explain the error when we attempt to redraw the schematic layout. Once we are satisfied with the building geometry, we can select the Greenhouse Materials menu tab to specify the greenhouse glazing properties. Greenhouse Designer models the optical properties of greenhouse glazing, including transmittance, reflectance, and light distribution. These properties can be independently specified for each wall and the roof. In addition, the floor reflectance can be specified. Glazing can be specified as clear, diffuse, or opaque. An advantage of this is that the reflectance of energy curtains and light pollution abatement screens can be modeled. Highly reflected curtains and screens can recycle the light in a greenhouse, significantly increasing the photosynthetic photon flux density, or PPFD, incident on the plant canopy, and in doing so save energy. Greenhouses can have one or more rows of tables per bay, where the table dimensions and spacing are user-defined. It would of course be possible for Greenhouse Designer to model more complex designs, but this is not its purpose. In architectural line design, an estimated 90% of projects involve nothing more than an empty rectangular room with a regular array of luminaires. Many architectural luminaire manufacturers provide simple online tools that enable users to specify the dimensions of these empty rooms, choose a luminaire from the manufacturer's catalog, and calculate how many luminaires are needed to illuminate the room. These are effectively quantity estimation tools that can enable the user to prepare an initial budget. Greenhouse Designer takes the same approach, but takes into consideration issues that are unique to horticultural line design. For greenhouses, this includes the roof design style, while for vertical farms, stacked trays are the most important issue. Following this approach, Greenhouse Designer represents plants as simple rectangular boxes, whose reflectance represents that of healthy green vegetation. We can specify the plant height above the tables. Choosing the appropriate plant height is important, as the canopy of tall plants, for example trellis tomatoes, will be closer to the luminaires. This will affect both the PPFD values and their spatial uniformity within the greenhouse. Luminaires are, of course, at the heart of horticultural line design for both greenhouses and vertical farms. Greenhouse Designer includes a database of horticultural luminaires from many different manufacturers, each with its own photosynthetic photon intensity and spectral quantum distributions. Greenhouse Designer relies on the ANSI IS TM3318 standard for electronic transfer of luminaire optical data to represent the optical properties of these products. In fact, TM33 was originally developed by SunTracker Technologies specifically for Greenhouse Designer before becoming an international standard. To choose a specific luminaire or browse for an appropriate product, we select the Choose button, which opens the luminaire database page. We can select the manufacturer's product by its catalog number, and we can open SunTracker Technologies Cerise Dots to view its luminaire optical properties. Cerise Dots displays all of the luminaire optical data present in the TM33 document in both tabular and graphical form. Here, the product spectral quantum distribution is displayed. Having chosen our luminaire, we can now specify the row and column spacing, the mounting height, and whether the luminaires are to be oriented parallel or perpendicular to the building length. Greenhouse Designer positions a rectangular array of PAR or quantum sensors with 2-foot spacing at a user-specified distance above the floor to measure the PPFD distribution. In general, we want to position the sensors to be at the height of the plant canopy. We can further specify the greenhouse's geographic location. With this information, Greenhouse Designer can calculate the monthly daily light integral, or DLI, values for its project report. Finally, we can specify whether the measurement units are to be imperial or metric. We would probably want to do this at the beginning of the project, though the default choice can be specified in the user account. Having specified the project parameters, we select the Build button. The Greenhouse parameters are sent to the cloud server, which takes less than a minute to prepare a computer-aided drafting, or CAD, model for the line calculations. This is where Greenhouse Designer differs from architectural line design programs. Without the unlimited complexity of architectural designs, Greenhouse Designer can use a parametric model to represent the greenhouse or vertical farm geometry. The model is basically stretched and extended according to the user-specified dimensions. The advantage, of course, is that the user does not need any CAD design experience or skills to generate horticultural line design plans. The resultant CAD design is presented as a so-called wireframe model that allows us to confirm that design meets our requirements. It is a three-dimensional model, and so we can interactively view the design using the mouse controls. We can also select the Toggle PAR Overlay button to view the PAR sensor grid overlay. In doing so, we can confirm that the PAR sensor height is where we expect it to be. If anything needs to be changed, we can do so and rebuild the greenhouse. Otherwise, we can select the Calculate button to perform the lighting calculations. Greenhouse Designer uses the same calculation engine that has powered architectural line design software for nearly a quarter century. It models both the light directly emitted by the luminaires and light reflected from illuminated surfaces. The calculation time depends on the number of luminaires and the size of the greenhouse, but in general, it will take only a few minutes to complete the calculations. The resultant photorealistic rendering shows the distribution of light in the greenhouse using white light. If the spectral quantum distribution of the luminaire is known, it would be possible to render the greenhouse using the light source colors, such as yellow for high pressure sodium or blurple, or blue and red LEDs. However, it is more informative to use white light. The rendering is also a three-dimensional model, and so we can interactively view the design using the mouse controls. We can also use the camera controls to select predefined camera positions, such as this top view. By selecting the Toggle Par Overlay button, we can display the spatial distribution of the PPFD at the height of the plant canopy. We can also choose an arbitrary camera position and orientation, and again view the PPFD distribution. We can further select the Take Screenshot button to capture an image of the rendering for inclusion in the custom report for a client. Greenhouse Designer can generate a comprehensive project report for the client with user-specified parameters such as target PPFD, photo period, facility voltage, electricity rate, and more. The report can be generated in various formats such as PDF, JSON, XML, and command-separated value spreadsheets by selecting the Generate Report button. It will take a minute or so to generate the report, after which the file will be automatically downloaded to the user's web browser. The default PDF report includes textual information regarding the client, project, building and table dimensions, luminaire, and report summary, as well as graphical displays of the PPFD distribution, the luminaire photon intensity distribution, and the monthly daily light integral report for the building's geographic location. Our next project is a trade vertical farm. The alternative is an enclosed room with plants such as cannabis placed on tables or on the floor. Greenhouse Designer again creates a default vertical farm for us with the design shown in the plan and elevation views. We can modify the room dimensions as needed, and also the room surface reflectances. The default model assumes 3 stacked trays, 2 of which are equipped with luminaires, but we can change this according to our needs. As with greenhouses, we can choose luminaires from the luminaire database and specify the row and column spacing on a per tray basis. We can then select the Build button to view a wireframe model of the stacked trays. Each tray, however, is individually illuminated, and so it does not make sense to render the entire room. However, we can select the Only Build Tray Model checkbox before selecting the Update Schematic button. This gives us the tray schematic layout showing the luminaire spacing, plant height, and power sensor height. Selecting the Build button gives us a wireframe of 3 trays in a row. The reason for 3 trays is that light from the luminaires of one tray will likely illuminate adjacent trays as well. Calculating the lighting for 3 trays in a row allows us to see the PPFD distribution on both the middle and end trays. Selecting the Calculate button gives us the PPFD distribution, where the differences between the middle and end trays becomes clear. Finally, we can generate a report that includes textual information regarding the client, project, building and trade dimensions, luminaire, and report summary, as well as graphical displays of the PPFD distribution. 3 trays are shown so that the PPFD distribution of both middle and end trays can be seen. The report also shows the luminaire photon intensity distribution, which can have a marked influence on the PPFD distribution with different plant canopy heights, This may prompt the user to specify a different luminaire or vary the luminaire spacing. This concludes the introduction to Greenhouse Designer. For more information, please contact Heliosol Software Solutions. Thank you.